Okay, I saw Alex's answer in the chat. So good job. Yes, the answer is B. Do you want to explain it to everyone through chat or like say it out loud? You can just say yes or no. Okay, and good job, Angela, too. Yeah, you can explain it. Are you going to type it out or just talk? Okay. So he's going to type. Okay, so he said because moving right to left is positive, that means that if you moved left, you're moving in a positive direction, and while moving right is negative. Yes. So that's correct. Yeah. So if people still don't get it, I'll write down basically what Alex said. So that means this way, the 32 meters is going to be negative because it said, like in the question, it says to the right is negative. So this way is negative. So your displacement here, this one is minus x2. So x2 is going to be 32. So minus 32 meters. And then this way is positive. So it's plus 17 meters. So it's 17 meters minus 32 meters, which is negative 15 meters for displacement. And if you're wondering, oh, do I put north, south, east, or west? Well, technically positive and negative also show direction, which you can see here, right? Because if you go to the left, it's positive, and if you go to the right, it's negative. So if something is negative, then you know that you're going more to the right. So that's where the direction comes from. And then distance traveled, you just add everything. So 32 meters plus 17 meters. You don't have to worry about the signs, which is actually why I like doing distance traveled calculations more, because you just add everything and you don't worry about a sign. And if you add those two, you get 49 meters. So 49 meters for total distance traveled, negative 15 meters for displacement, which gives us our answer of B. Does anyone have any questions, or like, do you want me to clarify anything? Just raise your hand or like say something or type in the chat. Okay, I think everyone got it. Also, if I'm going too fast, just tell me to slow down. Yeah. Okay. So yeah, our answer for this one was B. And oh, we have another practice problem now. It's basically the same thing. So I'll just read it off to you here. It says Tiana jogs 1.5 kilometers along a straight path and then turns and jogs 2.4 kilometers in the opposite direction. She then turns back again and jogs 0.7 kilometers in the original direction. Let Tiana's original direction be the positive direction. What are the displacement and distance she jogged? That was a lot of information. So my advice to you is to draw a picture first, which actually I'll just show you. Also, they never said which way is the original direction, so you can just pick your own. So you can say this way is the original direction, so that's going to be positive, and this way is the opposite direction, so you're going to say that's negative. And then this is Tiana. She jogs 1.5 kilometers in one direction at first, then she jogs in the opposite direction 2.4 kilometers, and then she turns back again and jogs 0.7 kilometers. So yeah, find delta x, so displacement, and total distance traveled. And if you still don't know how to do this one, just try this one first, because remember, for that one you just add everything. And yeah, don't convert to meters, even though that's technically the proper SI unit. But since your answer choices like A, B, C, D are all in kilometers, just leave it in kilometers. So yeah, I'll give you some time and wait until people start answering. And yeah, good luck. Okay, I saw Alex answer once again, and good job. You got it right. The answer is B, and it's for the same explanation as last time. So I'll just show you, I'll just write down what Alex probably did and what I did. So for displacement, you need to pay attention to which way you're going, because one way is positive and the other way is negative. So at first, she goes 1.5 kilometers in the positive direction. So you just write 1.5 kilometers. And then she goes in the opposite direction, so negative, so minus. And then she goes 2.4 kilometers. So minus 2.4 kilometers. And then finally, she jogs in the original direction again, so positive again. And it's 0.7 kilometers in that direction. And then if you do all the math in your head or with your calculator, you're going to get negative 0.2 kilometers for displacement. And then distance traveled, which is like the easy one, just add everything. So 1.5 kilometers plus 2.4 kilometers plus 0.7 kilometers is all equal to 4.6 kilometers. And if you look at our answer choices, negative 0.2 kilometers and 4.6, you know that the answer is going to be B. Also, I just wanted to point something out before we move on. If you looked at all these answer choices, and even if you had absolutely no idea which one it is, you can narrow down your choices by looking at which one is like impossible. So A is impossible because distance traveled always has to be positive because you're only adding things, right? So it has to be positive, it can't be negative. So yeah, it obviously can't be A. And if you're still a little confused on what like a vector or like a scalar is, so in this case, this one's the vector and this one's the scalar. Basically, vector is just like you want to see the overall direction and distance. So like after someone moves this way and then that way and this way and that way, you want to see in the end where they end up. But for distance traveled or like a scalar quantity, you want to see overall, like add everything. So the entire journey. So one is just like where you end up and then the other one is the entire journey, basically. I hope that made sense. Okay, we're going to move on to velocity, I believe, and speed. Okay, so speed. Speed is a scalar quantity. And so like you already know, it's not going to have a direction, just a number, and it's always going to be positive. Oh, someone said something. Oh, okay. So, you're welcome. And so speed is the rate at which an object changes its location. So if you have something like over here and then it can, I think, let me see, laser pointer. Okay, so if you have something over here and then it moves over here, you want to see like how much time it takes to go from here to here and also the distance between these 2 points. So that's the information you need for speed, and it'll make more sense once we start doing problems. And the SI units are meters per second, so like the official units are meters per second, but you probably know other units like miles per hour, which is like what our cars go at, or kilometers per hour, which is what cars in other countries go at. So average speed is written like this: S average equals the total distance traveled. Remember, now we know how to calculate this because from the problems we did earlier, divided by delta t, or the change in time. So yeah, we're going to be using that formula later. And for the change in time, if how you calculate it is the final time minus the initial time. So for example, if you have a ball that starts rolling at one point and you have like a timer, right? You're doing an experiment with the ball and then it rolls. You start the timer once it starts rolling, and then once it reaches like maybe the bottom, then you're going to stop the timer. So the first time when you first started it, that's going to be 0, right? Because you just started the timer. And then the final time when you stop the timer, that's going to be this TF right here, the final time. And yeah, that's how you would apply it in an experiment if they don't give you the change in time. But the problems we're doing later, they're just going to give us the change in time. And then there's something else called instantaneous speed, which is like the speed at a very specific point, because like something can have a changing speed, right? You can move really fast and then like slow down at this point and then move fast and then stop. So instantaneous speed is just time at a specific, speed at a specific moment. But we're not going to do that because like some of those problems are going to require a calculus, and maybe all of us don't know calculus yet. So yeah, for now we're just going to stick to average speed. Now let's try an example. And okay, it's a marble example. Okay, so a marble rolls 5.2 meters in 1.8 seconds. What was the marble's average speed? So always, like my tip to you is to draw a picture. So you have a marble. Okay, that's an odd looking marble, but moving on. And it goes 5.2 meters. And so this is going to be distance traveled, right? So dt equals 5.2 meters. And this entire journey takes 1.8 seconds. And since that's the amount of time it takes, that's delta t, right? Change in time. And our equation, our formula that we just learned is the average speed equals to total distance traveled divided by the change in time. So you can just plug in those numbers, 5.2 meters divided by 1.8 seconds, which is going to be equal to 2.888 repeated, which is meters per second, but we're going to round to 1 decimal point. So average speed is 2.9 meters per second. So yeah, that's the average amount. Like that means that in 1 second, this on average, this marble goes 2.9 meters. This is like average. And you can see our units came out correct because it's distance divided by time. So something in meters divided by something in seconds. So yeah, this is our answer. And now you're going to try a practice problem. So I'm going to read it off over here. A pitcher throws a baseball from the pitcher's mound to home plate in 0.46 seconds. The distance is 18.4 meters. What was the average speed of the baseball? And remember, I'm going to write down the formula for you. Equals distance traveled divided by change in time. Remember, draw a picture first if you're not sure how to approach the problem. And yeah, I'm going to wait until someone answers, or like 3 to 5 minutes. And I think Alex is gone now, so someone else answer the problem and type it in the chat. Okay, I'm just going to move on because this should be pretty quick. So if you figured it out, you probably would have figured it out by now. So how you would approach this problem is you don't need to know what a pitcher's mound or home plate is or any of that. You just know that from one point to another is 18.4 meters. And then the total time it took for the baseball to go from here to here is 0.46 seconds. So if you were to draw a picture, this is probably like something really basic that you could have drawn. So now all you have to do is just plug these numbers into this formula and divide. So 18.4 meters divided by 0.46 seconds. So the average speed comes out to be 40 meters per second. And we don't have a direction or a positive or negative sign. It's always just going to be positive because this is speed and speed is a scalar quantity. And so this is just our answer. And if we look here at the multiple choice, our answer is A. Okay. Now I have another problem for you. It's also average speed, so I encourage you to try it out. It's slightly more complicated, but I believe you can still do it. I'll give you a little hint. So, okay, Cassie walked to her friend's house with an average speed of 1.4 meters per second. The distance between the houses is 205 meters. How long did the trip take her? So, you might realize that we're actually not finding speed in this problem, but we're finding time, the change in time. So if you remember, the equation is average speed equals to total distance traveled divided by the change in time. So how can you rearrange this so that you can find an equation that gives you just this time equals to something? Because you're trying to find time, so you want your equation to be that way. Just time equals to something. So you can do some basic like multiplication. You multiply both sides by delta t. You can just treat this as a variable. So if you multiply both sides by delta t, you can cross that out because that becomes 1, and you get delta t times average speed equals to the distance traveled. But we're not done yet because we want it in just t time. So what can you do next? You can divide both sides by average speed. And if you do that, this cancels out and becomes 1. So your equation is just going to be delta t equals dt over average speed. So this is the really cool thing about physics. You don't have to memorize a bunch of formulas. It's better to just memorize like a few of the important ones, and then know how to use algebra like multiplication, division, adding, subtracting to rearrange your equation so you can find other things. So yeah, try this problem. This is going to be our last problem for today. Just find the change in time by using this total distance traveled divided by average speed. So you have like your average speed and your total distance traveled in the question. So really what you have to do is just divide two numbers. So yeah, that's my hint to you. And I'm going to give you a couple minutes to try this out. Okay, so for this problem, all you had to do is just use this equation and plug in. So we have the distance traveled, it says here, is equal to 205 meters. And then the average speed is equal to 1.40 meters per second. So from this, we can get 205 meters divided by 1.40 meters per second. And here's a really cool trick. You can cancel out the units to help check if you found like the right answer. So this becomes 1/1 seconds. So this seconds just goes to the numerator. And 205 divided by 1.4 is 146. So our answer is 146 seconds. And if we look over here, our answer is A again. Yeah. So yeah, that's all we're going to cover today. So like as a quick recap, what did we learn today? Today we learned what's the difference between a scalar and a vector. Remember, a scalar is something that is just magnitude, just a number with no direction. Like like 10 kilograms, that's just a number. And then a vector is something that has a magnitude and a direction. So a number plus and a direction, which can be north, south, east, west, or it can be positive and negative, like in the problems that we saw. And this scalar and vector idea is really important for almost all of physics, because there are going to be like different types of things that you try to find, and some are scalar, some are vector, and how you try to find those things, like the way you calculate them, depends on whether that thing is a scalar or a vector. And so, for example, distance traveled is a scalar. So I can go to the slides. Yeah, distance traveled is a scalar. So you just add everything and it's always positive. And then displacement is one way you call that the positive direction, the other way you call it the negative direction. So it's going to be like a positive and negative thing. So you find like the net displacement. So you can add and you can subtract, and displacement can be negative. And then we also learned average speed, which is a scalar quantity, so also just a number and always positive. And next week we're going to learn its vector counterpart, basically, which is velocity. So speed, you can't have negatives, but velocity, we're going to have some negatives. So yeah, thank you all for coming today and staying and listening, and I hope you learned something new. See you at the same time next week. Bye-bye.